Okay. I don't need synergy. I need this. Okay, here we are. Law of cosines. Law of cosines. We did the first problem the other day. This really helped second hour, and so I hope that it helps you too. But I just want to refresh your memory. We did finish this off, didn't we? Okay, so let me just, and make sure you have out your graphic organizer as well. We are going to refer to that. As we look at this triangle, we had A, B, and C. We had little a, little b, and little c. Here's what I want to show you. We had A is 26 degrees. You had B was 12. You had C was 15. And you solved for A and you got 6.74. Is that correct? So here's the problem, everybody. I want you to understand that side angle side, which is what we were given, true or false, you could use side angle side to prove congruence of triangles back in geometry. True. Side angle side was a good one. We said, yes, we like side angle side. Works great. So there's only one triangle we could come up with. However, sometimes people solve this and they don't come up with the appropriate triangle. And we talked yesterday about forcing out the obtuse angle. And the way that we did it is we solved for B first. What did you get for B? 51 about? So you got about 51 degrees. And what did you get for C? About? Okay, 102 degrees. Now, here's what I want you to understand. If we would have solved for C first, you would not have come up with 102. You would have come up with the angle in the first quadrant that represents the reference angle of that, or 78 degrees. That's what you would have come up with. Yes, that's wrong. If you would have solved for C first, you would have come up with that. Because you get like, you get like sine of theta is equal to 0.9. And you don't know whether it's there or whether it's there. You don't know which one it is, 102 degrees or 78 degrees. So here's what I'm trying to tell you. How did we know that when we solved for B that it was for sure the acute angle? Because there can only be one obtuse angle in a triangle. And if there was an obtuse angle, which one does it have to be? C. Why? Because it's got the longest side. So turn to your graphic organizer. Let's write this down, then we can move to our last problem. It says, when you are given side angle side, one solution, use the law of cosines to solve for a missing side. When you use the law of sines to find one of the missing angles, this is the part I really want you to focus on. Start with the angle opposite the shorter of the two sides. What will this do? This will force out the obtuse angle. Now, some people second hour said, Mr. Gens, I don't know what you mean by force out the obtuse angle. What the heck does that mean? I'm talking about what we just did. Look at this process. By solving for B first, I forced out C to be an obtuse angle, if it truly was, and it turns out it was. But if I would have solved for C first, I would not have gotten an obtuse angle. I got 78. So, okay? All right. Let's do example B. How is this one different than the previous problem? You have no angles. So I've got 9.1, 12.4, 10.5, yada, yada, yada. Okay? So I have absolutely no angles. So this is a side, side, side problem. Now, if you look at your graphic organizer, we're trying to solve for an angle. For these problems, you solve for sides. For these formulas, you solve for angles. Now, I'll tell you guys, I never saw these angle formulas when I was your age. And so I'm going to teach you the way that I learned it because I think it's most traditionally how people teach it and how you would see it in college. But note that if you wanted to, you could use these three formulas. And people use them all the time in trig. But I'm going to teach you how to use it doing this formula because I think that it's a little bit, just a little bit harder, but it's important that you see it now so that if you see it in the future, you'll know what you're doing. So the question still remains, is it possible that there's an obtuse angle? Yes. If there's an obtuse angle, which angle would it be? Angle C. Why? 12.4. Well, here's the interesting thing, you guys. When it comes to cosine, cosine has the ability to understand whether you're in the first or second quadrant. Watch. If I go sine inverse of 0.5, I'm sorry, negative 0.5, sine doesn't understand to get me over to a second or third quadrant. It gives me negative 30 degrees. But watch cosine. Cosine inverse of negative 0.5, you can actually come up with negative 120 degrees. So cosine is able to force out a obtuse angle. Law of cosines? Because we have side, side, side. So here's what we do. We start with the angle opposite the largest side in this case. And so we are going to solve for side C. So I'm going to use this formula. C squared equals A squared plus B squared minus 2AB cosine of C. That's what I'm going to use. So I have C squared or 12.4 squared plus A squared. Whoop. A squared is 10.5 squared plus B squared is 9.1 squared minus 2 times 10.5 times 9.1 times the cosine of C. So I'm trying to find the cosine of C. Now, I want to show you guys what I'm doing because I don't want to write this all out. I want to try to save space. I'm going to subtract the 10.5 squared over and the 9.1 squared over from 12.4 squared. That's the step that I'm doing right now. So I go 12.4 squared minus 10.5 squared minus 9.1 squared. Negative 39.3 equals, and then over here I need to do negative 2 times 10.5 times 9.1. Negative 191.1. Now, this is the last time I'm going to ask you to think really critically for the day. Just think about this. When I divide both sides by negative 191.1, will I end up with cosine equal to a positive value or a negative value? Positive. Where's cosine positive? First and fourth. Okay, so we're in the first quadrant. So is our angle going to be acute or obtuse? Acute. But let's say that it was positive 191. Then would I end up with a positive or a negative? A negative. Where's cosine negative? Second or third. So am I going to have an obtuse or acute? Obtuse. So see, that's what cosine is able to do. It's able to determine acute or obtuse. And so that's good for us. So I'm just going to divide both sides by negative 191.1, divide by negative 191.1. And so I can do cosine inverse of that. Cosine inverse of 39.3 divided by 191.1. And I get 78.13. Looks like I need to write down my values. A, B, and C. A, B, and C. It doesn't matter. I did it to save myself a step. So I have a is equal to, we don't know yet, small a is equal to 10.5, little b is equal to 9.1, little c is equal to 12.4, and angle C is equal to 78.13. Whoop. True or false? There's not an obtuse angle in this triangle. True. Because if there was, it would have to be angle C. So now it doesn't matter what we do from here. Well, how will you find A and B from this point? Law of sines, which you know how to do, so we're good to go. So flip to your graphic organizer, and we'll write in the last piece, and then we'll be good. If you are given side, 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 it says use. You have one solution. Use the law of cosines to solve for a missing angle. When you use the law of sines to find one of the other missing angles, start with the angle opposite the shorter of the two sides. Forget about that. That just matches with what we did over here. Just do this. It says just start by solving for the angle opposite the largest side. That is what you want to do. So, make sense? If you got questions about it, we can continue to talk about it, but we'll do some application on this next week, but we'll be ready to test next week. I mean, you guys have learned everything we're going to learn. Now we're going to do a couple application problems, which is no big deal. What? You sure can use them. You sure can. It doesn't matter. This is the traditional way of teaching it. This is the way I think most people have seen it. Solve for the angle opposite the largest side. Your assignment, page 518, numbers 1 through 14. The first few problems. Somebody did the first problem. They looked at me. They're like, holy cow. 6, 7, 8 minutes just to solve the first problem. I said, the first problem doesn't ask you to solve for the whole triangle. It just asks you to find one side. So the first problems are just looking for one answer. I then give you other problems that ask you to solve the entire triangle. So please take note of that. But page 518, numbers 1 through 14. Have a great weekend. I love math. So do you.